Okay, so I am going to use my Mobi board because I haven't recorded this lesson, and by now, I should have it start. This is called the cross product. So what the cross product does, okay, it is the cross product returns. So it's like U cross V, okay? It's another way to multiply vectors. So you have the dot product, which returns a scalar quantity, which sometimes you can use in finding the work done, or you could use for finding the angles between the vectors. There's other applications in physics that I'm not sure what they are. But U cross V has a very specific representation of what it is. Yes, ma'am. Yeah. And U cross V returns a vector. It returns a vector that is orthogonal. Orthogonal, meaning at right angles, to U and V. Okay, another word for orthogonal is what? Perpendicular. Okay. Still another word for orthogonal, which you may not, or may have heard of, is normal. Okay. So if they say this vector is normal to the two other vectors, it means that it's perpendicular. So if you have some vector going this way and some other vector going this way, the cross product gives you a third vector. So if this is, I'll show you, try to draw a picture of it, okay? So the third vector would give you a vector that is, let's see if I can do this. Boom. And, does that work? Kind of like, oh, that's wrong. Wait, let me try that again.
Between the first and the second.
Okay, so it's, if this is U and this is V, I got it now, okay? So that red vector is perpendicular to that vector, but it's also perpendicular to this vector, kind of like that. You see that? Okay. Yeah, it's possible.
It's like U's like going straight up.
So you could also think, so this, another way to think of this, you use the right-hand rule, okay? So here's vector U, here's vector U, your second finger, here's vector V is your bad finger, your thumb is the resultant vector that's perpendicular to those two vectors, okay? Okay, the direction of your cross product is important. So if I go like this, and this is U and this is V, then your cross product is going to go like that, okay? And so, so it returns a vector, and that has some applications in physics and engineering, obviously, right? If you have two vectors, you want to find a force that's perpendicular to those two vectors, you know. The way that you compute the cross product, okay, is by using a determinant. Remember determinants? U cross V is equal to, okay, you put an I here, you put a J here, so it's a determinant, except that, I'm really bad at making those K's, except that you put I, J, and K in the top row, and then you put the components of vector 1 in the second row, and you put the, whoops, that should be W, U's, sorry, I messed up. Those should be U's, not B's, okay? You put the components of vector U in the first row, and you put the components of vector V in the second row, okay? We'll do an example, don't worry. Okay? So if U is equal to if U is equal to I, I plus 2j plus 2j minus k. And v is equal to 3i minus j plus 2k plus 2k. Then u cross v is equal to, so you go up here, you put an I, you put a j, you put a k, and then you put the numbers. 1, 2, -1, 3, -1, 2 equals, okay? So so then you compute it this way. You okay? Oh, I didn't even write. It's okay. I didn't write the formula, okay? But we'll figure it out doing this problem. So what you do to do the determinant, you do the minor. Remember the minor? You cross out this column and this row. So it's that times I. So if I cross out this row, the first row and the first column, I'm left with in my determinant 2, -1, -1, 2. Do you guys understand where that came from? Okay. Then do you remember that it goes minus? Right? It goes plus. As I go across the top row, it goes plus, minus, plus. So then it goes minus the next determinant times j. What's the next determinant? 1, -1, 3, and 2, right? You cross out this column and this row, j. And then you go plus something, k. And to get that, you cross out this column and this row. 1, 2, 3, -1. No, not 1, 2, 3, 4. Okay? And then if you do that, so this is where people get, it's 2 times 2, right, which is 4, minus 1, right, because it's positive 4. That a minus minus makes a plus, but you subtract, it's this minus this times this, right? Which becomes 4 minus 1 in the I direction, okay? Minus, okay, what?
2, 1, minus
2 plus 3 in the j, right? Because it's this minus 3 times -1, right? So 3 times negative, okay? So plus 1 times -1, which is -1, minus 6 in the k direction. And when I simplify that, I get 3i minus 5j minus 7, sorry. Minus 7, minus 7k. Okay, so now we're not done. Just to kind of, I'm going to try to draw this for you. Here's my x, y, z axis. Okay, so if I have vector u, okay, let's do a different color. So here's vector u, which is out 1, this way 2, out 1, this way 2, and down 1. So maybe this is vector u, okay? Vector v says go out 3, back 1, up 2. So maybe this is vector, kind of hard to see, vector u. And then this one says out 3, back 5, and down 7. So maybe this is my resultant vector, like something that, it's hard to visualize, right? But if I did that, this vector here would be perpendicular to this vector, as well as perpendicular to that vector, which is kind of hard to see in 3 dimensions, but that's what you get if you get the cross product. Okay? You get that? Do you know what you get if, do you know why the chicken crossed the road?
Get to the other side. Get to the other matrix.
If you get this, you get a Tootsie Pop.
Oh.
Wait,
You get the Tootsie Pop.
because
Okay.
it looks better on the
No.
Jennifer Lawrence is in a tent.
No. The chicken crossed the road, He was trying to be normal.
Tootsie Pop.
I would know.
Yeah.
That sounds like a class.
But I say I get.
Cross.
He was trying to be
Brian's so
yes. Yeah. Go ahead. Where you're having coughing from. So, just so you know, U cross V is not equal to V cross U. Okay? They're opposites of each other. So what is true is that if I put,
Don't you want slash like in between the equals?
oh, it's not equal to,
Is there
sorry.
already a
Right.
Okay, what?
Is there already a
No, I'm posting it right now.
Okay.
Okay, so if I switch these two, okay, then I would get V cross U, right? And it turns out that U cross V is equal to the opposite, okay, of U cross V is equal to the opposite, is equal to negative V cross U, okay? In other words, if this is U cross V right here, then V cross U would be negative 3I plus 5J plus 7K. You got that? You understand?
Yeah.
So if I switch the order in which I take the cross product, I'm going to end up with the negative of my vector. Yes, sir?
Would it still be perpendicular to both of them?
Yeah, it would just be going in the opposite direction. So if this is V cross U, U cross V would be going this way. You see? Okay? It would be going in the other direction, which kind of makes sense by the, if you use your thumb and your, as the right hand rule, you can figure that. Okay? So, moving right along, properties of cross product. So, unlike a dot product, a cross product gives you back a vector. A dot product gives you back a number. Okay? So, for a scalar quantity. So, some properties. The first one I just told you is that U cross V is equal to negative V cross U, which is also equal to U, which is also equal to V cross negative U. In other words, like I can make this one negative and switch the order, right? Or I could make the first one negative and multiply them, and I would get the same thing as if I would do U cross V. Okay. Second property, another property, is that U cross U is equal to 0. Okay, because cross product returns a vector that is a cross product. A cross product returns a vector that's perpendicular to two vectors. So if I have the same vector, there's no single vector that is perpendicular to this vector in 3 dimensions, right? Because the vectors that would be perpendicular to that vector would make a circle, wouldn't it? Make a circle. Okay. So U cross U would be equal to 0. We have like the distributive property with cross products. U cross V plus W, where these are all vectors, is equal to U cross V plus U cross W. So yeah, that's W. So in other words, I could add together two vectors and then take the cross product of that with another vector. Or I can take the cross product with that vector and then take the cross product with that vector and then add them together. This would probably be easier to do because it's easier to add vectors than to take cross products of vectors, right? Okay. C times U cross V. This is kind of what this applies to this idea up here. C times, so this is a constant. Okay, like a number, you know. So C cross U, C times U cross V is equal to CU. Yay! Go Buffs. Cross V
Wait, wouldn't
It'll be CV.
whoops, no.
it be C?
It's equal to CU cross V, which is equal to U
T.
cross CV. Okay? So in other words, if I want to multiply the cross product by a constant, I'd say this number is 5. 5 times the cross product of two vectors is equal to 5 times the first vector times the cross product of V, or the first vector times 5 times the second vector with the cross product. Yeah?
Yeah.
Get it? Understand that property? U cross 0, guess what U cross 0 is?
0.
0, okay? Because if you think about that, say I have like I, J, K, and then I have some vector, say its components are 2, -3, 1, and then I put zeros down here, right? All my determinants are going to end up being 0, right? So that's how you get a 0, okay? Next property is U dot
That's the same
Um,
thing.
V cross W, V cross W is equal to U cross V dot W. What the heck does that mean? Is it U cross V dot W? In other words, if I have 3 vectors, this has a name too. Okay, this is called the, what's this called? The scalar, this is called the triple scalar product. This has a name right here. This thing is called the triple scalar product, okay? And that has a unique property as well, which I'm going to tell you in a second. But, so if I can take the dot product of one vector times the cross product of the other 2 vectors, and that's going to be equal to the cross product of the first 2 vectors with the dot product of the third vector. But again, the order in which you do this is important. With dot products, it doesn't matter which order you do it in, but with cross product, this is V times W here. It has to go U times V here. So it has to go in the proper order, okay? Triple, and this thing here is called the triple scalar product. Because what kind of number would I get if I multiplied those 3 things together? Would I get a number or would I get a vector? If I did this, I would get a number, because you're taking, this returns a vector, this is a vector, and a vector dotted with a vector gives you a number, okay? But the magnitude of this, or excuse me, the absolute value of this, U dot V, I'm going to put it on a new sheet of paper. So this is where it gets interesting. U dot V cross W gives you the absolute value of U dot V cross W gives you the volume. It actually gives you something. It gives you the volume of this word, parallel pipette with sides U, V, and W. So, do you know what a parallel pipette is? Okay, I'll show you. So, so a parallel pipette is just like a 3-dimensional parallelogram. So if I have one vector going this way, another vector going this way, and another vector going this way, okay? So say this is U, V, W, okay? In space, I don't know if I can do this. Can I do this?
You got it.
I did it in the last class. If I sketched in this, that doesn't work. Let me try again. 1, 2, so here's a parallelogram, right? A parallelepiped is a parallelogram kind of squished over like this, where all the faces are parallelograms, Oh, I drew it really well in the last class.
Like a Q.
Okay, that's,
Right.
that's bad. Oh, I have too many sides, don't I?
See it.
Oh, you see it? Kinda, okay?
It's so
Don't worry
easy
about
to
it.
draw.
U, V, W. So three of the sides are vectors, okay? And if I did this U dot V cross W, I would get the volume of this three-dimensional solid, okay? So do you want to? We'll try doing that in a second. No, we're gonna do it.
We won't have to draw it, will we?
No, you won't have to draw. Couple more properties. U, the magnitude of U cross V is equal to the magnitude of U times the magnitude of V times the sine of theta. And this is another way. You could use the dot product to find the angle between two vectors, but if I do some simplification, I get that the sine of theta is equal to the magnitude of U cross V, which is a positive number, divided by the magnitude of U, which is also a positive number, divided by the magnitude of V, which is also a positive number. So if I take the inverse sine of this quantity, I would get the angle between those two vectors. You know what I mean by the magnitude?
Yeah.
Magnitude. So if I say that U is equal to, I don't know, 3I minus 2J plus K. So the magnitude, yeah, you learned this yesterday. So the magnitude of U is the square root of 9 plus 4 plus 1, right? So the magnitude of U crossed with V would be something else. Yes, sir?
Why would you ever do that instead of just the U dot V?
I think the U dot V would be easier. But if they like give you the cross product and they give you the two vectors, then it'd be kind of, yeah, the other one's easier. With the dot product, it's easier. But the nice thing about this is always positive. With the dot product, you could get a negative number up here. But since this is the magnitude of U cross V, you're always going to get a positive. So it's always going to be an angle between 0 and 180 degrees. All right. And the last thing is that the area of a parallelogram, we're going to do one in a minute, okay? You're going to practice one. The area of a parallelogram, okay, is given with adjacent sides. That means next to each other, right? Adjacent sides U and V, okay, is given, U and V, here we go, is given by, okay, it's just the magnitude of U cross V, okay? So for instance, say I have U equals, let's make one up, I minus 2J plus 3K, okay? I'll make it easy. And V is equal to 2I minus K. Find the area of a parallelogram. I'm going to draw a picture of a parallelogram. I could do that pretty well. Of a parallelogram with adjacent sides U and V. Okay? You guys are going to try to do this right now. Okay? Real quick, I'll go real quick. Okay? Yeah, I will give you a Tootsie Pop. Just chill. Okay? I, J, K, 1, negative 2, 3, right? 2, 0, negative 1, right?
Yes.
So that's what you have to do. So this times this this times this minus this times this gives you 2i, right? Is that right? Yeah.
Oh, I thought
that's
it was
right.
2j
And,
minus k, that's what.
Yeah, because that's a k, right? And this times this minus this times this, it's minus 7, but the j is negative, right? So it becomes plus 7j. And then this times this minus this times this gives you plus 4k. And then you have to take the square root of 4 plus 49 plus 16, which is equal to the square root of 69. Okay, we got it. All right, so whoops, I was recording, right? I was recording.